Hey everyone, let's take a look at this fun number 13 here in section 10.1. The determine the limit of this sequence. So here's the general term, and it's quite interesting as n goes to infinity. Notice the base, right? 2 over n squared is going to 0, so the base is going to 1, but the exponent is clearly going to infinity. Well, 1 to infinity is indeterminate, right? The base, obviously 1 to any power, is trying to get closer and closer to 1. However, the base is always a little bit bigger than 1, right? It's 1 plus some small quantity, but it's still bigger than 1. And something bigger than 1 going to a larger and larger power is going to approach infinity. So the exponent's trying to get the limit to be infinity. The base is trying to get the limit to be 1. The limit could be 1, could be infinity, or it could be something in between, some finite number greater than 1. All right, so the way I'm going to do this is I'm going to let y be the limit we're looking for. And to really deal with that exponent, I'm going to use logarithm, right? Take the natural log of y. I can push the natural log through the limit because it's continuous on its domain. And then I'm going to make use of this property of logarithms to bring the exponent down in front of this expression. And now what's the form of our limit? As n goes to infinity, of course, n is going to infinity. And this in here, again, remember, is approaching 1, but the natural log of 1 is 0, so this is approaching 0. So this is still indeterminate form. The n is trying to make the limit go to infinity, bigger and bigger and bigger, but the natural log of this stuff is trying to make the product and the limit equal 0, get closer and closer to 0. So is the limit infinity, is it 0, or is it something in between? This is not something we can use L'Hopital's rule form on, but I can get there because n is going to infinity. I can rewrite this multiplying by n to dividing by the reciprocal, right? Same thing. Multiplying by n is the same as dividing by the reciprocal of n. And now notice the top as n goes to infinity is going to 0, but so is the denominator here. And that is L'Hopital form. Good, good. We can take the derivative of the top and the bottom, right? And take the limit and see what we get. The bottom, the derivative of 1 over n, right? Remember 1 over n is the same thing as n to the negative 1 power. So by the power rule, bring the negative 1 down, subtract 1, I get negative n to the negative 2, which I can write this way. The top is a chain rule, right? We've got the natural log of u, so the derivative is 1 over u times the derivative of u. So 1 over u is this part here, 1 over the expression in the parentheses. And then what's the derivative? What's inside? Well, derivative 1 is 0. And the derivative 2 divided by n squared, I wrote that as 2 times n to the negative 2. Power rule, again, bring the negative 2 down. I get negative 4 n to the what? Subtract 1 from negative to negative 3. So I get negative 4 divided by n cubed. Okay. And there's a couple ways we can simplify this to continue. What I did is I went ahead and multiply this fraction, this up top. So up top I have, multiply the numerators. I'll treat this as negative 4 times 1 gives me negative 4. And then this n cubed times the denominator, I have to distribute. N cubed times 1 is n cubed. And 2 over n squared times n cubed, well, 2 of the n's cancel, I just have 2n. Okay, so multiplying these two together gives me this. And now I have this fraction divided by this fraction. I'll multiply by the reciprocal here by negative n squared. Negative divided by negative is, of course, positive. 4 times n squared. And then the bottom is n cubed plus 2n. And what's the limit as n goes to infinity of this? Well, some of you know right away that the limit is 0. That's great. I can use L'Hopital's rule because it's really of the form infinity over infinity to prove that this limit is 0. I take the derivative of the top, which is 8n. The derivative of the bottom is 3n squared plus 2. This is still infinity over infinity form. So L'Hopital rule, again, derivative of 8n is 8. Derivative of 3n squared is 6n. Derivative of 2 is 0. And now what's happening is n goes to infinity. This is of the form 8 divided by infinity. That's determinate. That's going to 0. So that limit is 0. Remember, this was the natural log way back here. Remember, natural log of the limit we were looking for. So be careful. The limit of our sequence is not 0. The natural log of y is 0. Therefore, y is e to the 0 or 1, and the limit of our sequence is actually 1. Well, what a fun little sequence. I hope you had fun doing this one. I enjoyed it, and I hope this helps.